Hey, you crazy cats. Today we're going to be talking about getting prepared for this final exam. So, we're going to do an old final exam here and work through some problems. Start off with here. All right, we're going to have some true or false questions that are probably going to be pretty similar to this. And a lot of the questions that we're going to cover we've had in the past, so we're just going to go over them again. It is not appropriate to use an auxiliary view when a component of the part can only be dimensioned by using hidden lines. Well, it says auxiliary view. Well, there were three types of auxiliary views. Those three types of auxiliary views were section, correction, there were three types of alternate views. Those three were section, auxiliary, and the one where they blow it up. I can't think of what it's called. In a detail view when we wanted to blow it up. There we go. I don't know why that took me so long. So an auxiliary view was when we had something that was at an angle that was not going to be shown very well. I kind of used the example of the stapler in the classroom. A section view is when we wanted to be able to see the inside of something, and a detail is when we wanted to blow it up. So if we were hidden lines, you're talking about something that's on the inside. So it would not be appropriate to use an auxiliary view. So this right here would be a true statement. Now, you guys wouldn't answer it like this, obviously, on a test if you had a question like this, but this is a true statement right here. In the Cardboard Canoe project, after researching online for possible solutions, the next step is to build a prototype. Well, we're talking about here is the steps to the design process. And first one is you have to identify the problem. And I'm going pretty quickly here. The next one then is you've got to brainstorm or generate concepts. And actually, it's generate concepts is the step. And we do research and brainstorming during that. After you generate concepts, you then want to create a solution. After you've created a solution, you want to build and test. And then after you've built and test is when you would evaluate after you got your results of your test, and then you would want to present this to your boss or to the people who are looking at this. So it says in the Cardboard Canoe project, after researching online for possible solutions, the next step is to build a prototype. So you did your research, so you're not generating concepts. So what comes after generating concepts? That is create a solution. All right, so you're not building and testing a prototype yet, you are creating a solution. So this answer is false, and to fix it I would say create a solution. The reason why, you could say lots of things for the reason why. One reason would be that you would not want to build without going through the process of doing a decision matrix. And when do you do a decision matrix? We do a decision matrix in that create a solution process. Size and threading are not necessary to correctly dimension a hole. Well, if I was going to drill a hole, let's say I was going to drill a hole right here where my cursor is, right where it's dotting. A couple things we would need to know. First of all, I would need to know the size of that hole. How big am I going to make it? Then the next thing is, am I going to put any threads in it? So again, I would say this is a false statement, and I would say that they are necessary, and the reason why being that I need to know how big it is and if it has threads. I mean, it's real simple. All right, an improvement of an existing technological product, system, or method is referred to as invention. Well, we've talked about this a lot this year. This is a really big concept in engineering, IED, and when you're making an improvement or doing things like that to a technological product, system, or method, it's referred to as innovation because you're not inventing something new. And the reason why is just as I said, you are not inventing something new. You're improving a product. So again, you're not coming up with something new. You're just improving an existing product. An exploded view. All right, an exploded view is the most common method of communicating the shape and size of an object that is intended for manufacture. Well, an exploded view is we did there with our T9 cars when it was took the wheels and made them blew out the axle. We took out the rim. We blew out the tire and made everything really big. We separated everything. So this right here is not the most common method of communicating the shape and size. That would be exploded view is used for how we put things together or how it goes together. So in this we want here is a multi-view, and there's probably supposed to be a comma in there, so that's how I would fix it. And the reason is then is an exploded view, as I just said, is used to show how a product fits together. All right, there are 3 steps to reverse engineering. Functional analysis. So there's 3 steps. Let's just talk about what those 3 steps are. There is, we start off with the visual analysis, then we go to the functional, and then we go to the structural. Now in the visuals when you're looking at it and you're identifying all those principles and elements of design. We were talking about form, shape, color, line features, hue, darkness, value. We had like 14 different things or 15 different things we were looking at there. Functionals when we're talking about how does it go or how does it work. That was the black box. Functional is how does it work. And then structural analysis is what is it made from. So the 3 steps to reverse engineering. Functional analysis, the process of identifying the principles and elements of design. Well, that's not functional analysis. Functional analysis is the process of learning how the product works. And the reason why I would say is the principles and design and elements of design is the process of visual analysis. John used many horizontal lines in his design of a sports car that can go 200 miles per hour. So this is talking about then that visual where we're talking about that elements of design and principles of design. Horizontal lines didn't show us movement, and that's what we're trying to say here. So what did show us movement? That was diagonal lines. Diagonal. There we go. Diagonal lines. And what might be the reason why? Well, I would say horizontal. If diagonal lines are used to show movement, then horizontal lines show peace and calm. Designers use proportion to show illusion of a 3D on a 2D surface. Okay, they don't use proportion. In this case, they're going to use value. They use form. Either one of those 2 things I would accept there because value is the shading. Form is anything that has 3-dimensional shape. It has form. Like a triangle has shape, but a box has form. A circle is a shape, but a sphere has form. And my reason why for this then would be, let's talk about proportion. Proportion is when a drawing or design is in shape or is in size with how it would be in real life. And examples I used is uh, if a picture has an apple being as big as a person, then it's not in proportion. If the picture has the apple being the size of about someone's hand, then it is in proportion. And it's really just that simple. All right, let's look at this next problem. What type of fit would you recommend for the axle body? Well, if you remember, we had three types of fit. We had a transition fit, a clearance fit, and an interference fit. Transition is when it would go from slightly, it would fit in there, and then you had to maybe push it the rest of the way. An interference fit would be there's no way it was going to fit on its own. It's going to have to be hammered in, and then a clearance fit would be like a bolt falling into a hole. It's just going to slip right on through, no problem. Well, in this case, I would suggest that you either use an interference fit or a transition fit. Transition so you could get it started, and then interference so that it wouldn't come back out. And I would say that's probably what this axle is, because this part is probably going to fit in the hole, and then right here we have the ridges was going to be the part that makes it so it doesn't come back out. So I would say we probably have a clearance fit. Calculate the following for exterior axle pin diameter using your dimension suggested dimension tolerance. Show your work. Well, okay, so we got a lot of things here. We got some vocab here we're learning here about specified dimension of the axle. So that's how big do we want the axle to actually be. And if we look up here, we want the axle to actually be 3. This is the specified dimension right here, the 0.300. Now for the hole, what's the specified dimension for the hole? 0.305. This over here is the variance, all right? The 0.06 and the 0.02, that's the variance. The upper limit, well, all right, I'm just going to do the axle in this case. The upper limit is how big it would be, 0.300, and then I'm going to add that 0.02 to it, and that's going to give us an answer of 0.32, and that would be the upper limit because we've just simply added the variance to the specified dimension. Now the lower limit, we would subtract the variance from the specified dimension. So that's going to be 0.3 minus 0.02, and that's going to give us an answer then of 0.28. That's how we would find the upper and lower limit. So the tolerance of the hole. Well, I'm going to do that same thing over here. They've given us 0.06. So tolerance of the hole is the upper limit minus the lower limit. And in this case for the hole, the upper limit is 0.365 minus 0. And that's going to be 0.305 minus 0.06. When you do that, you're going to get 0.245. So when I subtract those two, we get 0.365 minus 0.245. And then we get a tolerance, which is the upper limit minus the lower limit, of 0.12. So I would come down here and say 0.12. And that's our tolerance. This last one right here, this allowance slash interference. This right here was quite some problem for some students as we were going over allowance and interference. I'm going to go down a space here. Our equation for allowance, I'm just going to say A slash interference, was equal to the MMC of the interior feature minus the MMC of the exterior feature. And what we're talking about here is when When does it have the maximum material? All right, when does it have the most material? And in this case, our interior feature is when we'd be measuring inside. And that's going to be the lower limit then of the hole up here, because we'd be measuring the inside. You stick the ruler on the inside, so we would be doing the interior. We'd be measuring on the interior of the part, and that's going to be the lower limit of the hole. In that case, that would be 0.245. 0.245, which we already calculated earlier, this right here to be the lower limit of the hole. Now the maximum material of the exterior, because we've been measuring from outside to outside here. We want we've been measuring the exterior part of the axle. And to do that then would be the upper limit of this, which we did right here of the axle. That was 0.32. So when we subtract these two, we get negative 0.075. And it was negative. So what did that negative infer to us? Well, that told us then that it was not allowance, but it was indeed interference. Meaning that you're going to have to pound this axle into this hole quite often. Well, hey, I hope that helps you a lot with this. Your guys' job is going to be to finish this. I'll catch you guys on the flip side.